the simulation model using O2DES, I want to introduce a go through of all the essential step or knowledge. I think it's important. I hope this can be helpful. And also, like before I really start the introductions, I want also to say that I want this session to be more interactive in the sense that whenever you got any questions regarding what I'm introduced, okay, feel free to speak it out. Okay, ask the questions in the session. And also you can raise up your hands. Okay, so if I did not notice your icon, then please someone just unmute your microphone and remind me. Okay, so hopefully I can use this session to have a more interactive and effective training to all of you. Okay. Yeah, so let's share my screen now. Okay, can you all see my screen?
Yes.
Okay.
You can see your screen.
Yeah. Okay. So I think this session, instead of just going through all the slides, actually you see that these slides I prepared here are quite like fragmented. It's actually I'm not planning to go through the slides one by one, but rather I use a slide to draw something, to prepare something. So later when we touch into a concept, I will shift back to the slide to show you, to illustrate those concepts to you. But I think mainly what we are going through is we will have some like a hands-on experience. I will show you that how to prepare the development environment and how to come up with a first model, etc. By go through about this programming and coding. So I will use this one to have a better way to show you how to build this model. Okay, but rather like go through the slides. So I think the first sessions, what we are going to do is that actually three main objective of the first part of the training today. The first one is that I'm going to show you that how to prepare this development environment. Okay, so what software we need to install. Then when we install, so what are those things we need to pay attention. Then the second one is I will show you that how to quickly to come up with your first simulation model by using O2DES. Okay, so most probably this is just a hello world program. So it can be done very fast. Okay, if you just want to get the simulation down and run, okay, it can be very fast. Then using this a simple example, I will show you some of the very important or most fundamental concept about the discrete event simulation. And after that, I will try to extend this hello world model a little bit, okay, to show you some of the more advanced concepts. So I think this is the plan for this session. Okay, so let's go to the first part. Okay, I will show you that what are the software we need to install, okay, in order to have this to prepare the development environments. Okay, so basically what we are going to use is actually this Visual Studio. Okay, you can just type the Visual Studio. Okay, then you can go to that. You can go to that. Yeah. Okay. Then in the Visual Studio, we just need to select this community version, which is free and download. Sorry, I think because my system is default language is Chinese. But yeah, I think the English will exactly have the same layout. Okay, so just choose the community version, you download, then you clear this file, then you can actually install the Visual Studio. Okay, that's because I already have the Visual Studio. So I think what I'm going to have is to show you the installer. Okay, so when you open this installer file, okay, so several things you need to note that Visual Studio actually is not, sorry, it's not updated. So actually the Visual Studio is not only for C# programming. Okay, it's not only for C# programming. So it can support a multiple language like C#, Visual Basic, and also the like F# or other like languages. So that's why when you install the Visual Studio, you actually need to select that what are the, sorry, I think this update may take some time. So let me find some of the image file, okay, to show you that what are things we need to pay attention. Yeah, I think it's okay. All right. Okay, so when you start the installer, so actually it will allow you to select some of the functions you are going to install. So because now we are using the O2DES.NET, which are programmed in C#, so what you can do is you just need to select this .NET desktop development, this module. Then, I mean, if you want to have some like UI developments, so you can also select this one. You also Windows Platform developments, okay, and also, I mean, if you just want to focus on the modeling, you can only select this one. It should be good enough for just doing the modeling. And also this .NET Core cross-platform development, you just need to like tick this one, okay? Because now is the O2DES framework we're building is actually based on the .NET Core. So that it supports a cross-platform. It can be used in Windows, can also be used in Linux, okay? So that's why I think I'll take this one. And beside this one, you can also shift to the individual components. Okay, so I think one of the things I suggest you to select is actually under this code tools. Maybe you can select this class designer. So later, I mean, in the later part of my tutorial, I may show you like sometime I may show you this class diagram by using the class designer to draw. Will be very useful for you to understand the whole picture of your model. Okay. Then after that, the language packs, you can select English, or some of you are more familiar with the Chinese simplified, traditional, then you can also click the other language. Okay, so in that case, after you select this one, just click next, okay, when you install it. Then after waiting until all got installed, then that's all you need to prepare for the IDE, the integrated development environment. Okay, then after that, you actually can have this Visual Studios installed in your computer. So what you need to do is just open this Visual Studio 2019. Okay, then you come to this kind of page. Then you just click this continue without code. Okay, you can actually open this environment Visual Studio 2019. Okay, so now we want to create the first project. Okay, so what we are going to do is we create this file, new project. Then we need to select the language we want this project to be, and also the type of this project. So here we are looking for this C#, okay, console app bracket .NET Core. Okay, we select this one. Yeah, but also you see that for some of the other project in a more advanced version, so actually what we can do is a C# like UWP project or the other project. Okay, so now for this tutorial, I'm going to use a console application. So the input output will be simply through the console window. Okay, so we click this one, then next. Okay, now we're required to input a name of this project. So we can give any name. So for example, this case, I just type hello world. Okay, then location default, solution name default. Okay, create. Okay. So one thing I want to mention here is to get you familiar with the structure of the source code under a C#, okay, C# the project. So you can see on the right-hand side, this is a solution explorer, okay? So we have this purple icon here showing solution. Then we have this green icon here showing this is actually the project, okay? Both have the same name, okay? We have a solution with the name of Hello World. We have a project name with the name Hello World, okay? But we need to see that these two are different. So we have one solution. Under this solution, we have one project of Hello World. So actually, this solution, we can actually add in another project. Okay, we can actually adding another project, okay, but still putting on this solution. One solution may have a multiple project. Why is sometimes we actually want to separate the different layers of a program into the different project. For example, some project just for model, okay, then the other project for UI, then the other one more project is actually for analysis. Yeah, something like that. So in that case, we don't want to put all the functionalities into one project, but all these are two different projects together actually form a solution. Okay, we're going to deliver to our clients or the stakeholder. So that's why one solution may have a different project. And also is that under one solution, we can actually have a different project. So we have actually cross-reference a project under the different solutions. For example, on this solution, under this solution, now we have a hello world, but we can also adding another existing project. Okay, so this project can be something I did before. Okay, we can add another project, for example, O2DES. Okay, then we click this one, they will also be adding into this solution. And because in this new solution, we found that some of the project we did before probably can help. We can reuse some of the code. So that's why we also like add them in. So this actually one of the things you need to know whether something is under solution or under the project. Okay, so now you see that in this newly created project, we only have a one source file program, okay, which is here, okay, which is here. Then what this program is doing is just print out a message to the console. So they have this statements, console.writeLine hello world. Okay, so this is actually a very like a typical or default C# console program. So what you can do is that you can play these things, okay, and see what the result of this program execution. You can see that this hello world is printed out here. So this is actually the hello world program for a C# okay, program. But now what we are going to do is we want to show you that how can we come up with our first simulation model, okay, for the hello world. So what does this mean? I want to use this. I want to use this one, okay, to show you. So what we are actually simulating here. For example, now we have a virtual world. Okay, now we have this virtual world. Okay, then every sometime, maybe like every second or every 5 minutes. Okay, here. Okay, it can this might not be a constant time, but it can also be some of the random time. So later I will show you the this deterministic version and also the random version. Okay, I mean every certain time interval there will be like one new arrivals to this world. So then this person may say, hello world. Okay, so let's simulate this kind of the scenario. Okay, we don't care where this person come from. Okay, we just care about this part. We have this world, then we have a person that keep coming to this world. Okay, so this actually is something we are going to simulate here. So what we are going to do now is first we need to include the O2DES framework, the library, okay, the package, okay? So where is a package? Where is a package? Actually, it's very simple. We don't need to go to a website to download, but rather just under the same environment, the development environment, we goes to tools, we goes to NuGet package manager, okay, NuGet package manager, manage NuGet package for solution. We click this one, okay, then browse in the browse window dialog box. We just type O2DES, okay, probably net, okay, O2DES net. Okay, then you can select the first one, O2DES net. Okay, then install to this project by clicking tick this project in front of this project. Okay, then click install. Okay, so now it's successful. Okay, but if you are not sure whether the installation is successful, what you can check is go to these dependencies here. You click this one, click a package, then see that this O2DES net package with the correct version is already installed here under this project. Then it's successful. Okay. Just in case that you have a multiple project here, then you need to tick multiple project, and also you can select that which project you want to install and which you do not need to install it. Okay, and later you need to correspondingly check each of the project to see that whether the correct package have been installed. Okay, so by now, if you have installed this one, I should say that all the environments we need to prepare for building a simulation model in O2DES.NET is done. Okay, it's completed. Then what we are going to do is to start to build this model. Okay, to start to build this model. Okay, so I want to introduce a little bit of concept on how we actually doing this. So we actually have this concept of the sandbox. So what we are going to do is whatever we are simulating now, we keep them in certain kind of the sandbox. The reason is because we want to separate it out, okay, from all the other environments. For example, the other environments, what we are going to do is probably some of the analysis, we want to look into the historical data, etc., in the outside environments. But when we simulate, this simulation can be based on historical data, can also based on some things which are not happens in the history. So that's why we want to create a safe environment, okay, to encapsulate everything just inside. this environment. So that's why we have this sandbox concept. Okay, that everything we build into the model will be kept in this sandbox. Okay, so in that case, let's create our first like sandbox, or this sandbox, maybe we call it the world. Okay, let's just call this a sandbox. We name it as a world. Because it's a sandbox, so what we are going to do is we need to extend this one from the basic class of the O2DES net. So what we are going to do is have this a comma O2DES net dot sandbox. Okay, so what does this mean? This statement, okay, is actually to say that now I'm creating a sandbox named as a world. Then this is a type of the O2DES net sandbox. Okay, so meaning that here is actually a template. We have all necessary functionalities, functions already building into this template. So what you are going to do is you create a new one. I mean, for yourself, for your program. Okay, let's say that this sandbox you are creating is one type of the sandbox which actually defined under the O2DES net library. Okay, so actually this is the meaning of it. So what we are going to do is we need to specify what do we have, okay, in this sandbox. So if according to the problem I just described to you, okay, so what we are going to have is that we need to define this event, okay, of a person like arriving into this world. Okay, so this event we call hello world. Okay, so the way we define an event under the maybe we call this event arrive. Okay, I think this will be simpler. We call this event arrive. So the way we define an event under the O2DES net is that we use this one. This is a syntax. Okay, I think by now just need to remember. So later I'll explain what does this mean. Okay, so we have a void, then give an event name called arrive. Okay, bracket. So we can simply define an event in this way. Then we just need to write whatever you want this event to do, okay, inside this bracket, inside this range of a bracket. So what we are going to do with these things, with this event is we want to print out, okay, we want to print out a message of hello world, okay? Oh, maybe just a differentiate from the hello world from the outside program. So what we are going to do is hello world in O2DES. Probably. Okay, so in this way, we actually define the event of this model. Okay, but this is not sufficient. Why? It's because you actually tell the program to say that, okay, in this world, in this model, in this sandbox, there is an event called arrive. Then this is what it's supposed to do in this event. When this event is invoked, is a trigger. But you did not tell the logic that how this event will be triggered. What is a dynamic mechanism for this event to be executed? Okay, if you remember, if you refer to this one, we actually define this arrow, but we did not define the logic, how this arrow will be triggered or will be invoked. Okay, those are dynamics. So this will be the next things we are going to do. Okay, so how to define the behaviors of this event? Actually, here we propose two ideas. One idea is that, okay, so once there's one event happen, I will schedule the next event, the same things, after 5 minutes. Let's ignore about the randomness first, okay? Let's just say I want to schedule a next event after 5 minutes, okay? So this is actually the first things we are going to do, okay? So how do we do this? After printing out this message, so we just use schedule the same event called arrive after 5 minutes. So we have the time span dot from minutes. So actually this is the way of the C# to tell you a time span or duration. Okay, we use the time span dot from minutes 5, meaning that it actually create a new time span from the minutes which this number tells. Okay, so this actually say I want to schedule the next event after 5 minutes. So this is the first things we want to do. Okay, then the second thing is, okay, think in this way. The second event, the first event will trigger the second event, then the second event will trigger the third event. The third event will trigger the fourth event. I mean, so on and so forth. Okay, so I think this logic is clear by this statement. But who will be responsible to trigger the first event? These are some things are not clearly defined here. So that's why we need to answer this question. Okay, how do we schedule the first event? So fortunately, I mean, object-oriented programming or C#, okay, just the image and the C# actually provide this a function to show you that, okay, every object, including a sandbox, okay, you actually have, you need to define a functions to construct it, okay, meaning that you're actually creating these things from nothing to a project, okay. So what does this mean? This meaning that, okay, here you see that in this class, we actually define what is supposed to be in this, the sandbox called the world, okay? But after you say, you specify all the things, there is nothing in the computer. It's just like a script, okay? Just a script to see that how this thing should be made. But we really need to make something when we execute the program. We really need to make this a sandbox, okay, so that it's available for you to play, to test something. So we need to define that when we make these things out, okay, so what should we execute, okay? So how do we specify those information is that we have this a constructor written in this way. Okay, we have this a world bracket. So you see that there's a special things you can observe to check whether this is a constructor is that this name should be the same as the name of the class, okay, of the sandbox you're actually creating. It have the same name, okay. Then it need to have a public this in front to show that, okay, anyone in the program, okay, who are using this program, using your package is able to construct it. Okay, so this will become a public constructor. Okay, then here we do not have any parameter, meaning that in order to construct, to build one like a toy, this is a sandbox, you do not need to pass in any parameter. So let's do this in the simplest way. Okay, so this is a public word. If we just do not specify anything, then it will just do nothing. It will simply give an empty sandbox. But now is that we want to say something, okay? We want to do something at the time we build this sandbox. What we are going to do is we want to schedule the first event, okay? First arrive event. So what we are going to do is we will schedule this arrive, okay, at the current time of the sandbox. Okay, so what is the current time? I will explain a little bit later. Okay, here I just say that if we do not specify any time after schedule, meaning that the schedule is at now. Okay, this now is actually referred to the simulation time. So what is the difference between the simulation time and the CPU time, the clock time, the work clock time, the real time? I will explain later, a little bit later. Okay, so now let's just do these things. Remember that this is actually for us to schedule the first event of the arrive at the current time. Then the first event happens, it will trigger the next one after 5 minutes. Then the next event will trigger the third event after 5 minutes. So this will be the logic. Okay, so I think after this, we have already like construct the first sandbox. Okay, then we will go into the program to show you that how do we play with this sandbox. So in that case, we do not need this hello world anymore, but rather we need to write some script, okay, for you to get this sandbox, to create this sandbox and play with it, okay, to use it. Let me just do it this way. Okay, later I'll explain so what is the meaning of it. So the first I create a object called a scene, okay? So I'll let it to be a new world, okay? Then after that, I want this same to run for 10 times, okay? What is a 10 times mean? Later I will explain, okay? So let's play with this and see what is happening. Okay, you can see that 10 times, meaning that 10 events actually executed. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, exactly 10 events are executed here. Okay, so this is actually the meaning of this 10 here. Okay, so by this one, you actually can see that we actually define this only 2 times. Okay, we make define the actions, the behaviors only with this 2 statements. but rather later when we come to this program, we can see that we simply like type a 10, then we can see the simulation can actually run for 10 times, repeating actually forever. I mean, if you like continue to give another command to run to see for another 10 times, if you don't believe, we just change this number to 100, you can see that, okay, these things can actually repeat forever. Not forever, for 100 times. But if you want to do it forever, then just have an infinite loop. Okay, so but actually, we are not really satisfied with this kind of simulation. Okay, so you just like print out, the message 100 times. So what's the matter? Okay, so what's the matter? I mean, we can actually write a for program. Okay, the for loop to help you to do this. Okay, so the reason is because actually we can use this one to like track the time when this event is happening. Okay, so now this time is determinate. I mean, the inter-arrival time is deterministic every 5 minutes, but later we can actually add a randomness or add a lot of logic into that. Then it will become more and more meaningful. But now is that in order to like show you that the clock is actually running. So we're going to modify this program a little bit to show you that what is the clock time we having now. Okay, what is the simulation time we're having now? So basically what we are going to do is we modify this line 16. Okay, basically we just insert one thing called a clock time. Okay, so this clock time is some of the properties already defined under the sandbox. It's a standard. Okay, it's actually a property from the parent class so that we can call it directly. So if we put these things, we can see that just now we run 100 events, right? So here we are able to like clearly indicate what is actually the time. Okay, this event is executed. So the first one is 0 minutes, 5 minutes, 10 minutes, etc. So every 5 minutes, we actually observe there is a one hello world event happening. There's a one arrive event happening. Okay. So this one is we successfully like showing the basic functions of the O2DES model. So if you're able to do so, meaning that you have already built your first simulation model here by using O2DES. Okay, so now is that I just want to go through these things, this model a little bit to show you some of the important concept. Okay, I want to demonstrate to you. Okay, the first one is that, okay, just now we say that this is a schedule. Okay, this is a schedule. We have arrive followed by 90, meaning that it's actually scheduled at the time now. And also we can do this thing. Okay, also we can do this thing. We can follow by clock time. So actually it's meaning that this is actually a time now. Okay, it's a time now. So this is no difference from just execute the schedule. So here I want to emphasize one of the concept. The important concept is actually this cross time. Okay, so actually this cross time is actually the concept or terminology which actually brings a lot of ambiguities when we talk to other people about the simulation. For example, usually, I mean, in our team, we have this discussion. How long have you run your simulation? I run it for 100 days. Huh? You spend 100 days to finish the simulation experiment. No, it's because we simulated for 100 days. So what is the difference, okay, between these two persons when we discuss is that they did not really like highlight the clock time when they say the 100 day, whether it's a simulation clock time or is actually a CPU time. Or CPU time is actually equals to a real world time because the real world time actually are reading it from the computer. So that's why we make it CPU time. So we need to differentiate these two things. The clock time here is a simulation time. It's not the CPU time. CPU time is something you can read from here. Okay. But this clock time is something only in this sandbox. It's only in this sandbox. So you see that this sandbox, we actually have a clock here. Okay. So this clock time only refers to the time of this clock. It has nothing to do with the CPU time. It's nothing to do with your watch time. It's nothing to do with your with the real world time. Yeah, you can actually consider this sandbox as a parallel universe, which actually have a totally different space and time with the universe we are currently live in. Okay, so probably you can like bring this concept in, so that as a kind of like a god of this small sandbox world you are actually creating, so you can actually play with the time, you can control the space, you can play with the time of this small world. You can let it to run faster, slower, or you can pause it at some time. So all the things it does is within this small universe. Okay, so this actually the first concept you need to know is that this clock time refers to the simulation clock time, which is different from the real world. So I suggest that the next time when you talk about anything related to the time of the simulation, better adding this word is a simulation time, or it's actually a CPU time, or it's a computational time. Okay, so this will be very different. So as an example just now, I run my simulation for maybe 100 simulation days. Okay, for example. Okay, then it will be clear is that you are not like waiting there for 100 days for 3 months, but rather it's actually a virtual world you are creating. There's a 100 days past. But if I like use another way to say, I run my simulation for 5 minutes of CPU time. Okay, 5 minutes of the CPU time. Then it's clear that you're actually waiting there for 5 minutes. Okay, for the simulation to finish. So I think this is one of the important concept we need to know. Then I think I also like want to specify some things on the difference between time point and the time span. Okay, or maybe the time point in C# is called a daytime. Okay, and the duration in the C# is called a time span. Okay, so let me just write it out. Daytime is actually one like a data type of the C#, then time span is another data type of the C#. What is the difference? Daytime is a time point. For example, now I want to schedule my array event. I didn't know, I don't know whether, I mean, some of you have realized the difference of these two. Okay, what is the difference between these two is that this is actually a time point. Okay, when we see the clock time, it's actually a time point, which are dimensionless. Okay, just a one point, it have a no duration, no length. Okay, but when we see schedule here, it's actually a duration. So this actually have a two meaning. So if you want to say a time point, it means that you actually schedule the events exactly at this time point. But if it's a duration, it's actually saying that you are actually schedule events from the current time, then you delay for this duration. Okay, then you schedule event at that time. So this is actually two different ways of make a scheduling. So if you understand that what I said just now in a few sentences, so you can see that this schedule arrive 5 minutes later is actually equals to say that's a clock time plus this 5 minutes. Okay, or maybe the other way is this one clock time at minutes. Actually, this got the same meaning. Okay. So what we are doing here is instead of given a 5 minutes delay as a duration, so what we are going to do is that we use a current clock time, we add another 5 minutes to it to make it another time point after the 5 minutes. Then we use this one to schedule this event. Okay, so this actually have the same, exactly the same meaning as what we had just now. Okay, exactly have the same meaning as this one. Okay, so I think this is another thing I want you to differentiate is the difference between a time point in C# we call date time, and the other thing is the duration in C# we call the time span. I think this is the second very important concept. Okay, then also one more things. Okay, I want to highlight to you is a different way of play with the simulation model. Oh, before that, I want to show you that why we are doing this way. You see that we're actually building a model at one place, but we're actually running and using a model at another place. So why we are doing in this way? So I think this is actually a basic idea of the object-oriented programming. Let's use this one. You see that our name of this framework is called object-oriented discrete event simulation. But I think very well that people may understand why this is called object-oriented simulation. It's because we're actually following object-oriented programming paradigm. So what is a major difference, okay, or specialties of this object-oriented programming, and what is make a difference between the other way, which we call the procedure-oriented programming? So if it did not say whether it's a procedure-oriented or object-oriented programming, so if it just say programming, so what does this mean? Okay, actually, I mean, just a few days ago, I read a very introductory course my son is reading to teach the kids that what is a programming. Basically, it say that programming is a way that you come up with a list of the instruction for the computer to execute. Okay, so if you based on this kind of the definition, then clearly you will see that have an impression that, okay, this is the way how the program should be. You have a starting point, then you follow by step 1, step 2, step 3, some condition, then you check whether yes or no. If no, doing something, then look back to some step, etc. Okay, then it's actually this kind of a procedure you define for the computer to execute, okay, for the robot, okay, the computer to execute in order to complete something, okay? So if you just write your program in this way, this is called a procedure-oriented programming. So this has been the start of the programming for a few decades, okay? But later, people found that, okay, this is actually effective and also very useful when you're dealing with some of the very simple task. And also, I remember the time I just I did my first year undergraduate course in engineering faculties. So actually, this is the way we teach the programming. Okay, and also I believe that in most of the programming course, this is actually the way to teach a programming at the beginning. But the thing is, when the system become more and more complex, okay, so there will be multiple kind of the jobs, okay, the computer is supposed to do. Okay, so if you really look into this kind of the flow, it will be like 100,000 or maybe an uncountable number of the procedures, possible procedures. I mean, the system is supposed to go through, to execute. So if you write all of them in this kind of structures, then you'll see that you have a lot of repetitive work, programming work we need to do. And whenever there's any a mistake, it will be very difficult to check where is the problem. So that's why I think in 1990, I don't remember exactly the time, but yeah, having already a few decades that people have been proposing this idea of the object-oriented programming, okay? So that the way we do it is that we actually encapsulate this procedure and all the variables needed by this procedure into a concept called a class or maybe object, okay? So that we can define multiple objects, okay, for this program without really go through the entire decision, entire procedures, okay? But what we do is that we link them according to certain procedure. For example, one object can be a car, one object can be the engine, the other object can be the door, the other object can be the tire. Then we can see that, okay, one car will consist of one engine, maybe 4 doors, 4 tires, etc. Okay, so this is what we program. This is what we're building when we do the programming. Then we can see that the engine is supposed to do something, okay, only within the scope of the engine. Then the door also do some functions within the scope of the door. Then the tire will do something within the function of the tire. Okay, then what we do is when we assemble all of them into a master apparent object called a car, then a car can do a lot of things that individual component cannot do. But the thing is, in order to finish, okay, what is supposed to be done here at a car level, then each of the component is supposed to do their own job. So this is actually a concept of the object-oriented programming. So that you can see that when we program for this car, we don't need to specifically describe the procedure of each flow. We can just call the subcomponent to complete their a submission. So at this level, you just need to see that how to coordinate different components to work together. So this has been a way of doing the programming for a few decades, and now this is actually exactly the concept we are building our simulation model and using our simulation model for the analysis. Okay, so let me show you how do we reflect this concept here. In this part of the source code, the only things we are doing is actually we are building this component. or we are building this product. This is a sandbox. So this sandbox, basically you can think this as a toy. Actually, we're actually building a toy, or more precisely, we're not building the toy, we are defining the toy. We say that this toy should have this event. This toy, when they start, it should execute these things. So we're not building a toy here, but rather we are defining the toy using this kind of the script. Okay, then go to the program. Where is a place we really build this toy? Is here. Okay, here we are saying that, okay, now I want to, according to this script, okay, I want to build a toy, this word toy, okay, the toy which have the name of the world, okay. Then I want to name this a specific toy object as sim, SIM, okay. So this will become a model name. This will become the name of the specific object of the specific toy, belongs to yourself, belong to this program you are executing now. So I mean, in that sense, you can actually create another toy, a different toy called a sim2. It's also the same time, the same type of the toy, the sandbox. Okay, you defined just now, but it's actually a different object. It's a different object. It's a different world. Okay, so if you think about the world concept, it's actually a different world. They have a different clock. They have a different event. You have a different things, event happening inside. Okay, so after like creating this world based on the definition we define here, then here is actually a way we play with it. Okay, this is actually the way we play with it. Just as what I described to you now is when we define an object, we do not really care that how do we use it. We just specify if someone want to use, this is something you need to do. Okay, but really using this object and execute some function is actually some things after you define this module. So it's exactly what it's doing here. After defining this simulation model, so only here we are conducting the experiment on this simulation model to do something. So here is as simple as just run for 100 events. But I think in the future tutorial, or actually in our applications, in our centers, actually we have already done a lot of like other more complicated experiments with interactions with the simulation model. For example, we can do warm up, we can do pause, we can do like some reading, some abstract some of the information, etc. Okay, so this is actually how we play with this toy, with this world. Okay, but now we only show one way of interact with it by telling what is the number of the events. Okay, we are going to execute. Now it's 100. But also we can do this in other ways. For example, another way of calling it is to say that, okay, you run for 1 hour. Okay, you run for 1 hour. So what we are going to do is this. Okay, instead of to see 100 events, okay, we run for 1 hour, then we play. You can see that without touching any change in the toy inside, we just change the way we play with it. So we can actually control arm. It will actually run after 1 hour. It will terminate here. Okay. And also, if I have another way to say that, okay, I want to run until the end of the first day. Okay. So what does this mean? So I need to create a date time. So this date time will become the, let's do it this way. Simulation clock time now plus 1 day. Okay. Okay. So actually, I'm creating a timestamp. Not timestamp, the time point. Okay. I'm creating a time point which actually 1 day after the initial simulation clock. Okay. Then we let the simulation to run until that time. So let's see what is happening. Yeah, so may run for a while. Okay, you can see that simulation actually stop at the beginning of the second day. Okay, and also you can also specifically, explicitly like define what is terminate time you wanted to reach. So what you're going to do is you create a new date time and to say I want to run until the first year, the first month, the second day with 0 hour, 0 minutes, and 0 seconds. Okay, you want to run until this clock time. So it will show the same thing. Okay, that's what we have just now. But if you don't believe that these are some things I had just now, so maybe we change this a little bit. Okay, I change this to 23, 59. Okay, then 59 seconds. Okay. So you can see that it's run until the next event at 23:55. Okay, but why not is 23:59? It's because there's no events. Okay, after this, there's a no event after 23:55 until the terminating time of the simulation clock. So that's why this event is not shown. Okay. So here I just tell you some of the alternative way of controlling the simulation. To make it short, you can control by the event and also control by number of event, control by the time span, can also control by the daytime. Also another things I think I need to like introduce to you is that the simulation run without giving anything. So what does this mean? Okay, so basically this means the same as this one. Okay, one event. So if you just run these things, it just will execute the next event. Okay, you will have. Okay, so if you don't believe, I will write these things multiple times. Okay, you can see that exactly we'll just execute the 3 events. Okay, so this actually introduces different ways of doing the simulation run control. This one we actually call is a run control. Okay, so this is actually the Hello World program I want to introduce to you now, okay, as a starting point. So now what we are going to do is we need to slightly expand, okay, this is a Hello World program to introduce a little bit more concept related to the O2DES framework. Okay, so the first things I want to introduce to you is actually the randomness. Okay, the randomness. You see that just now what we have is every 5 minutes, okay, a schedule arrive event. But in reality, this is not something we want to study in most of the cases. I mean, if everything is deterministic, why not we just write a mathematical programming model, or maybe just write a formula to calculate it out, okay? The importance of simulation to many people is that it can actually be able to capture the nature of the stochasticness. Okay, so when things goes to random, which people cannot see directly using a closed form formula, then simulation will become a better approach. So now what we are going to do is we want to change the constant arrival, the inter-arrival time to a random number, okay, to a random number. So what we are going to do is we just simply change this part. Instead of to say every 5 minutes, we schedule the next arrive event. So what we are going to do is we generate a time span from a random distribution. So what can we do? We use exponential. For example, we are now, so say we want the random number, random variables follows exponential distribution. So what we are going to do is exponential. Yeah, maybe we do it in this way. The full namespace should be the O2DES net dot distributions dot exponential dot sample. Okay, then we sample something. Okay, what is the something I later will say. But because this O2DES distribution is some namespace, so I can make it here. Okay, put it here, so it will be easier for the code. We just say O2DES net dot distributions. You may ask, what is the usage of this namespace? Okay, it seems very complicated. Yeah, actually, I mean, if you have some like a little bit more coding experience, you may found that it may be quite often that sometimes we have a duplicated, okay, name for the variable. Just to give you one of the very common example is a queue. Okay, you see that in the algorithm and the data structures, actually queue has some meaning to see that it's actually a first in, first out, okay, kind of data structure. Yeah, so yeah, I mean, if you have learned some things on the algorithm data structure, you should be familiar with this one. But if you come to the IE domain, okay, when we talk about the queuing, okay, when we talk about the MM1Q, MMCQ, queuing theory, then the queue will have a totally different meaning. So if you just use a queue, then people cannot differentiate. Are you talking about the Q of the data structure, or are you talking about the Q of the queuing theorem? Also, another thing is actually events. C# have got something called an event, and also discrete event simulation, we also got something called event. Although there's certain like similarity, but actually it's a different things. We actually define it as a different things. Such event is not the event on the C# is not the event of the discrete event simulation. So in that case, we need a namespace at least for us to differentiate, to say that when you talk about the exponential, so this is actually exponential under the O2DES net distribution. It's defined under this namespace. Then when you say exponential, they only got this meaning. Okay, so this actually to avoid any ambiguities here. Okay, so here is actually what I mean. But if you like have several like distribution, for example, let me show you another example. Is actually we have one thing of MassNet. This is another like library. Actually, O2DES is using. Okay, also got numerics distribution. You can see that both of these things will have an exponential. Then here, this exponential does not really know which exponential actually you are referring to. Okay, so in that case, we need to pay attention. Okay, so we just need to code. But what happened if you need to use a two exponential at the same time? Then here you still need to like explicitly tell that which namespace it come from. Okay, so by the way, I think I don't need to worry about this. This is actually some of the side story. The only thing you need to know is that you just call this a name of this random distribution, then come up with this a sample. Then you need to give this a parameter. Okay, you need to give this a parameter. Sorry, yeah. Okay, so the parameter will be the average, the expected time. Okay, will be 5 minutes. Okay, but seems there's one thing missing. What is the thing missing is the random stream. This is also another very, very important concept I want to like emphasize to you. Okay, let me just close this bracket first. Okay, so the first, remember that when you want to come up with certain like a random distribution, a random number, okay, for the time, this is what you require to do. Okay, get the distribution name, sample, give a random stream, maybe just follow default RS for most of the case. Okay, then give the parameter. So here, this parameter is a mean value. How do you know this is a mean value? Okay, just retype this a comma. Then you foresee that this time span mean. I mean that here this is 5 minutes, meaning that this is actually expected value, the mean value. Okay, what does this random stream mean? Okay, so this is a random stream meaning that when you actually draw some random number, this random number is not totally random as you think in the real life. Real life, random number means what? Means you throw a dice, okay? You roll a dice, then the dice will show some number. Then this is a random number. Meaning that the second time you roll a dice, the dice will be very unlikely to show you the same number, okay? This is because in real life, you cannot really like play back the clock. You cannot say, I want to repeat my yesterday. You cannot do this thing, but simulation world actually can. We can actually repeat the first day simulation for many, many times, as many as you wish. So we need to create a certain mechanism to ensure that every time you repeat the same day in the same universe, in the same world, it will always give you the same kind of the random number. Okay, meaning that if you revert your clock time, you roll a dice again, the first time you need to get this number. Second time you need to get another number. If you want to repeat the clock, I mean the same sequence will follow. Okay, so this is where the random stream will be important here. We need to make sure the random stream is something we are controlling. Okay, we are controlling. But you may say that why is it necessary for you to do so? This is actually because we are doing our simulation for analytical purpose. Okay, for example, we are actually using our simulation model for port planning. Okay, for O2DES, for another terminal. But the thing is, if you identify to say, okay, at a certain time, certain minutes, hour, minutes, second, there actually a certain bug, or might not be the bug, maybe a problem of the designing. Okay, for example, we identify a deadlock because of the controlling rules is not clear or have some like limitations. So we identify a deadlock. So we want to analyze what is a deadlock. Because of that, we actually revert back my simulation to run it again. maybe just stop at the 5 minutes before. We want to see that what was happening at that time. But actually we found that because of randomness, the second time, a totally different scenarios actually appear. So this is not the things we want to see. What we are going to see is what we expect to see, that if we want to repeat, just stop at the 5 minutes before, if you repeat exactly the same scenario as we analyzed the last time. So in that case, we can actually conclude, we can collect more data to like support our justification, okay? So in that case, we need to control that the random stream we are using should be the same. Okay, so this is the purpose why this random stream is important. But here is that we're using the default random stream. But how do we control? How do we like actively control this random stream? For example, sometimes we want this to be same, sometimes we want it to be different. Later I'll show you very soon. Okay, here just need to remember when you want to generate a random number, this is something you need to refer to. Okay, so after this, we just simply, actually this is the only part we change from the model just now. It just spend a lot of time telling you a side story. Okay, but just to make this change, you play your model again. Okay, then you can see that it's not exactly 5 minutes, okay, the time interval, but rather it's different. Okay, sometimes it's 1 minute, 1 minute. Wow, actually it's very small. Why the mean is 5 minutes? Because we did not run it for long enough. Okay, let's remove these things. Okay, we still use this run 100. Okay, 100. Then we can see that, okay, so the okay, the first you see that the first event, the first 3 events, the time is exactly the same as we show just now, because the same random stream was used. Okay, but you see following that, you can see that some of the time can be larger than 5 minutes. Okay, can be larger than 5 minutes. For example, this is 6 minutes, or it can be more. But in average, I mean, if you are patient enough, you just go through all the numbers. Okay, then you can actually see that the average interval time will still be 5 minutes. Okay, because we are draw this random number from an exponential distribution with set parameter. Okay, so this is about how to come up with a random number, okay, for the timing. But now the next question is, I want to know that how this default random stream is built. The reason is because sometimes I want to change this random seed, okay, to observe a different sample, to observe a different observation. Because if you only use one random seed, then people may not trust your simulation study. They may say that, okay, your experience, your solution is only applicable for this scenario. So if you change to another scenario, whether your approach, whether your study, your conclusion are still valid. In order to answer this question is, for our simulation study, in most of the cases, we should run it with a different random set. Then only when we get a conclusion, which are come from the multiple replications, then we are able to say that we have a high confidence to say that this is actually the conclusion. We have a high confidence to say that this is the solution we are going to use. Okay, so how to do this thing, I think this will be a separate story. I think maybe Prof. Lee last time have already mentioned about how to do the replication, how do we do the variance reduction output analysis, that eventually come up with this OCBA concept. So I think this will be another story, but here we focus on the modeling to see that how we make this possible. By changing a random seed number, we can actually change it to be a different replication. But later, if we use back the same random number, we can get exactly the same replication back. Okay, so these are some things I want to show you. Okay, so this story will come to this default random stream. This default random stream is actually some things we build defined at the parent class, meaning the templates. Actually, this is some things we build in this sandbox templates. So in order to affect those things that happen in the template, we need to call back the constructor of the template. How to call back this constructor of the template? We simply do this. We do this column base. Okay, something. So what we are doing here is that we are calling back the constructor of the sandbox, of the parent of the template. So here, how do you think? You can think of your word as some things your company are building. For example, you are actually are managing a company, running a company, building a toys. Okay, then you have one model of the toy called the world. Okay, this is a toy you build. But actually, when you build this a toy, you do not build this one from scratch. Rather, you have another company which actually provide you the template for this toy, or maybe provide you some of the components. Okay, it's basically like the Apple, they're building the Apple phones assembly from the some things like produced from a lot of the supplier. So it's the same thing. You actually call your supplier to say that when you supply your template, okay, you need to consider one thing, which is a random seed. Okay, so here you can see that this base actually they have this seed parameter there. So if you tell your supplier to say that now I want the seed to be 0, okay, then when you are building your world, actually you are calling your supplier to build a template for you. Then you do some further processing. Then you can see that the random stream building into this template will be different according to this number. So if you change from 0 to 1 to 2, then you can actually see that, okay, the result is showing, if you still remember, the 3 time, which at the beginning, actually got changed, okay? So actually the default number we use is 0. So if you set it to 0, is exactly what you see just now, okay, in the first case. But now you can simply change this to another number, just to be a 1. Then you will see that the result will be very different, okay? Very different in the sense that statistically they are still the same, not much significant difference statistically. Okay, but if you look at individual timestamp, it will be totally different. Not totally, because it can be also lucky that sometimes you got the same. But yeah, most likely, I mean, it will be very different. Okay, so this is how do you change a seed. But if you want to say that I want the end user to be able to play with this seed, I want the end user here to be able to play with seed. Yeah, this is actually very simple. You just expose this seed as one parameter here. Then you just pass this seed to your supplier. Then you're able to achieve so. Okay, you can see that here. I can actually play a seed here too. Then that's wrong. Okay, we'll get a different result. Okay, so this is how you can play with a different random seed. And usually you see that this kind of structure we can actually simplify because C is actually the first parameter. So what we can do is, you can see that C is actually the first parameter. So actually what we can do is basically seed. But rather here, for this world, we can also do this equals to 0, meaning that if the end user does not provide any parameter, then default you can use 0. Okay, so this is something here. So if the end user does not specify any parameter, then according to this definition, okay, we can actually use 0 as a default value. Okay, so this actually illustrated how can we use the random stream and controlled by the random seed. Okay. Okay, moving forward. The next story I want to share with you is how do we parameterize the toy? Okay, parameterize this world. You see that in this world, there's nothing we can do to configure what should happening in this world, right? So every time, I mean, beside the random seed, but as I just said, when you change a random seed, you do not really change the behavior of the whole system because statistically, they are not the difference, okay? But the thing is, if you really want to make a difference to the world, actually, this is the purpose of our simulation analytics, right? Simulation optimization, simulation analytics is that we want to find the best solution, okay, to this world underlying the study, okay? So that's why when we come up with a simulation run, we need to say, we want to configure it in a different way. We want the service rate to be lower, higher. We want the queue to be longer, shorter, etc. We want the capacity to be 3, 4, and 5, something like that. Okay, and also it's like I want the port design to be parallel layout, to be perpendicular layout. We want how many blocks, etc. So this is all considered as a configuration of the simulation model. Okay, but here I want to illustrate to you that how can we configure this world we're building here. Okay, so if you look into this model, so what is a potentially will be the configuration of this world you actually underlying study? Potentially is here. Okay, potentially is here. I want to, yeah, probably I can use back the PPT to show you a better view to see that. Okay, so now, yeah, we know that this is a world we are going to look at. People are keep coming to this world. Every time you come, you will see a world, say hello world. But the thing is, the rate of the arrival for the person who come into this world might be some things can be controlled, or maybe we want to like study a different arrival rate. Okay, so in that case, what we are going to do is we'll expose these things, okay, to a parameter of the simulation model. So how can we do that? Okay, so what we are going to do is we define this arrival rate, okay, the arrival rate to be a parameter of the system. Okay, so we write in this way, I will explain. So what does this mean? Maybe to make it more precise, we said this is the hourly arrival rate. Okay, so this is to avoid any ambiguities. Then if you really like want to like give more description, what you can do is here you would like keying this slash 3 times. Okay, then you can actually get this summary. You can give a comments to this one to see that this arrival rate meaning that the average number of arrivals per hour. Okay, so this actually give a meaning of an hourly arrival rate. Okay, and here we see that this is the sum of the properties we need to define, okay, for this world. Then all the execution of this world, the dynamics and behavior were based on this parameter. So that's why instead of to say that it's every 5 minutes, what we are going to do is we use 1 hour divided by 1D divided by the hourly arrival rate. Why is a 1D is 1 can be integer, okay? So 1D meaning that it's a double, it's actually a decimal value that is a double precision. So yeah, and also I mean similarly you can also write in this way 1.0, but 1D will be more precise. Okay, you use a 1 divided by the hourly rate. Okay, so this one actually give you in average, what is the inter-arrival time in hour? Yeah, because this is hourly rate, right? So if every hour is a 5 coming, meaning that in average will be 20 minutes. Okay, or maybe make it simple. We just use a 60D. Okay, divide by the hourly arrival rate. Okay, then you can see that this will become the mean inter-arrival time. So in that case, you can see that if this value is changed, then the whole behavior of the simulation will also be changed, right? But we need to find a way to like set this value. How can we set this value? Okay, we put it here. For this world, okay, not only the seed is required, okay, but actually the seed is not necessary to be required. Not only the seed can be changed, we also need to pass in another parameter called hourly arrival rate. We'll set this one as the parameter to be passing for the end user. It's like when the user, you open your box, you open your toy, the box of your toy. The first thing you need to do is you need to set the parameter. What are the parameter? What are the hourly arrival rates you want to you want this toy to behave? Then inside the toy, we need to link this input parameter which user set it, okay, to the internal properties which is defined here, so that this value can be used by the internal logic. Okay, you see this is a way. Okay, so I show you that how do we use this thing. Okay, by defining a word, we'll see that the hourly rate will become, for example, 10. So every hour it will be 10 arrival. Okay, then instead of to run for 100, let's do it this way. I just want to control it by the time span. Okay, maybe just from the 1 hour. Sorry. Okay. So the simulation will end after 1 hour. Okay. then you can see that, okay, so we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, slightly more than that, okay, slightly more than 10, yeah, because the interval time is actually random, okay. But what you can see that is that this number of events is actually depends on the parameter you're passing. Okay, if you don't believe me, I will change this number to be 20. Okay, then you see that we actually got more events. Okay, because the error rate got increased. Okay, then if you want to decrease this one as 3, then we see that the number of events is much shorter. Okay, much smaller. Okay, so this one is actually to tell that we can configure our simulation model before let it run, and you can not only you are not only be able to like control the setting, the configuration, but also the random set. So if you get these two, then the first one is actually for the hourly rate, the second one will for the seat. But this one seems a little bit not that straightforward to see. So in C#, it's better you can do in this way, so it will be clear to the user. To I want to set the error rate to be 3, seat to be 0. Okay, you can see this will be the case. Okay, if you just want to like vary my seat to be 1, but error rate will be the same, then you see that this time we got a smaller. Okay, by just changing the number of the just change the seat number. Okay, so this is about how to set the simulation model to configure it. Okay. But why we are using this one? You see that this kind of structure a little bit strange. Probably this one, I think most of you can understand that, okay, because a rate can be a decimal, can be a decimal number, fractional number. So that's why you put at a double, so you can have a higher precision. But why you have this a public, you have this a private here. So this a public actually meaning that this actually are some things you can query from this model, from the user, from the end user. For example, in this program, I can actually print out after simulation run. Probably I can print out to say that I want to see that maybe I just forgot. For example, this is some things are keying by the users. So later I want to see that what is the error rate to actually set for this simulation model. So basically you can just query for this one. Okay, you can just print out this message. Okay, that's wrong. We can see that after finish, we just say the hourly error rate we say is 3. This is possible is because you set this value to be public, so that from here you can see. I mean, just make a change by change this to the private, etc. Then you can see that this program, you'll see there's a wrong. You cannot see it. Okay. Yeah. So this is the reason why this to be a public. But why this need to be a private? Okay, why the setter need to be private? So I think first I need to explain the getter and the setter. Getter meaning that this is a get, meaning that you actually read the value from this parameter. Set actually meaning that the way you write the value into this parameter, okay, into this variable. Okay, so right in this way meaning that the getter is public, or maybe the whole parameter is public, but just that the setter need to be private. The whole parameter should be public, yes. Then the setter need to be private. So what does this mean? It's meaning that from the public is read only. Yeah, I think this is the same meaning. From the public is read only. From here, the end user is read only. Why is it read only? It's because I don't want the user to like change the value of these things in the middle way. Okay, while the simulation is running, then it changes value. These are something that I don't want to see. That's why after simulation is constructed here, I want it to be these things is a read only. Okay, so this is the reason. Okay, and yeah, so this is the reason why the setter is set to the private, because it's a private. Okay, so here we can actually change within the world. I mean, within the model, within the sandbox. Yeah, because we are actually the manufacturer of this sandbox, so we are free to do anything, and we know how to make it safe. So that's why it's the private. Then we can actually do the setting of the value here. Then in the program, we only allow this setting to happen at the beginning. The end user build it. Okay, it's like an end user open this box of the toy. Okay, only at that time they're allowed to set it. Okay. Another thing is we want to set. Okay, we want to okay. So this is about the configuration of the model. Okay. Now I want to talk about another things, which is actually the collection of some of the running data. Okay. For example, let's come to this one. We're not satisfied with just observing anyone arriving to this world to say hello. Okay, does not make any sense. Meaning, I want to at least come up with certain things, okay, for us to understand how many have arrived in this world. Okay, so in that case, we need a kind of the counter, okay, inside the model for us to collect this kind of the information. So in that case, we'll create another one called public integer. Then we just say it's a we give a name of a count. Then the same, okay, we set the public because I want to query from the end user. So that's why the getter need to be public. And also I do not want the end user to set it. Rather is that only inside the model, inside the sandbox, okay, then we're able to change this one according to determined logic, okay. So this account can be, the value of account can be set, but we do not allow the outside the user, the end user, to play with this number, to randomly, to anyhow arbitrarily set a value to this value. We don't allow. So that's why the setter is private. So you see that we actually have a both a private, but actually the reason behind is very different. Okay. So this one is we do not want to change in the halfway to affect the simulation study. Then eventually you come up with this result. You don't know that where this result come from. Okay. And this one is because this actually is something dynamics happening inside. So we only want the simulation logic to change the value. We do not want the people to interfere with the value of this thing. So there's a different reason. And you see that this all count, this account, actually we can consider this as an output of the simulation, right? I mean, the input, the simulation does not depend on this value, but rather this value is something we observe from the simulation. So that's why this value is something we generated from the simulation. So that's why we need to do one more thing, which is to set the initial value for this account. Okay, because we do not expect the user to pass in this value. It's not like our hourly error rates, but rather this is something the simulation should set. So we first need to consider is what to set the initial value. Then later we'll see that how to change this value. So that's why here in the constructor, you see that all those initialization things we put into the constructor. In the constructor, we do this count equals to 0. Okay, so that the initial value of this count equals to 0. This is reasonable, right? At the beginning of the world, there's nobody inside the sandbox. Okay, but we can also do this in this way. We put the equal to 0 behind. So this is equivalent. Sometimes this will be easier. Okay, so this is how we set the initial value. What we are going to do is every time when someone comes in, instead of just say hello world, we want to increase this value by 1. So what we are going to do is count plus plus. Okay, we let this value to be increased by 1. Yeah, it is possible because it's allowed privately. Private meaning under the sandbox. Okay, so that's what we can do. So okay, so yeah, this is something we have built. So now we come to this program. So besides just telling this arrival rate, let's do in this way. Okay, so just remember that this is a standard way of output some message in in C#. Okay, so this will be the hourly arrival rate will be this variable. Okay, after this string. Also, we want to do the similar things. Console.writeLine. Okay, to see that this will be the total count. Okay, so how do we query this number? Simply sing.count. Got these things. Okay, so we click the play. You can see that. Okay, after we run it, we see that okay, total count is 2. Let's try another seed. Okay, to be 2. Then we can say this time we got slightly more. Okay, total count is 5. Still 3, but the total count after 1 hour is 5. Okay, because it's random. Okay, so this actually tell you that how do we collect the basic information from a simulation model. So now let's review what we have done here. Okay, we see that we look into this model we have built. This is actually the event, right? Now we only have the one event. Okay, so this is what we need to do in the event. And here's a constructor. Is what are the initial things you need to set? You need to set the initial value. You need to set the initial event. Okay. And beside that, we have these two properties of the sandbox. But these two properties seems very different for us. One property is actually for configuration. The other property is for the observation, okay, of the model. Another way to look at that is that this is the input of the simulation model. This will be the output of the simulation model. Also, we have another view of looking at that is that this is some things which are not changed throughout the simulation run by definition. Okay, I mean sometimes this value also not change because of nothing happened. Okay, if you change our rate to be very low, so you run for 1 hour, if nothing happened. But what I'm saying is by definition, this is things is not supposed to change. Okay, because it's actually configuration of the system. These are some things supposed to be changed or allowed to be changed, right, from time to time, because this is something we want to observe. So as a simulation is running, then the value need to be changed. Otherwise, we don't need to observe, right? If we know this thing does not change throughout the simulation, then we don't need to observe. We know what is the value at the beginning, okay? So this is supposed to be changed. These things are supposed not to change, not supposed to change. We call this a static parameter, static properties. And this one we call it the dynamic property, or maybe we call static components or the dynamic components, okay? Then this we call events. So now this will be clear to us is that this will be the configuration of the simulation model we call the static, which is telling scenario, decision, or environmental information. It all goes to this part. This will become an input of the simulation. Then inside the simulation, we go through a lot of the events. Okay, the event will trigger each other. Events will do a lot of other things, print out message, processing some of the variables. Okay, then we have this dynamic properties. Okay, which actually indicate the state of the simulation. And also you see that the events is actually used to update the value of the state. Okay, so in this case, usually when we write our simulation, we do in this way. So we say that this will be the statics of the simulation model, static components of the simulation model. Then we have another region called the dynamics, okay, of the simulation model, okay. Then we also have events. Okay, we have events of the simulation model here. Okay. Then we got this constructor. And usually this is a constructor we put at last. Okay. And also that this is a usual ways we define our simulation model. We always come from the statics, okay, to see that how do we define the system, okay. And dynamics is what we need to observe from the system. And we come up with events. So what is actually the dynamics, which trace the dynamic information to change from time to time, okay. Then we look at what should we do at the beginning of the simulation. So basically we use these 4 steps to specify the simulation model. Okay, then after this, a model is supposed to be done. Okay, so by this, I think we're not only coming out with our first simulation model, but we also is able to understand the most fundamental concept under the O2DES framework. And sometimes I call this a 3-component paradigm, modeling paradigm, 3 aspect or 3 component. Okay, basically mean that we have this static, dynamics, events. So last time we also observed very interesting. So if you take initial letter of this 3, exactly is DES, discrete event simulation. Okay, consists of the dynamics, events, and the statics. Okay, so these are some of the interesting findings last time. Okay, so Sijie, may I know that what time are they supposed to end?
It's actually, I think it's 1.5 hours until 4.
Okay, until 4. So we still have 5 minutes. Okay, so let me just quickly go through one of the another things. Is actually the maybe 2 more things. One is actually the event diagram. Okay, the event relationship diagram. So if we want to like represent what we are doing here, okay, in this Hello World program, in the way that most of the people in the world are doing the discrete event simulation is able to understand. So this will be a formal description of the model. Okay, so what is this model is doing? So actually this should be the arrive. Okay, this actually will say that this circle is actually the event. It's an event we actually defining here. It's an event we are defining here. Then this event will trigger another event. So you follow this arrow, you'll see that this event will trigger another event. In this case, is actually it's itself. Then we have this time delay follows exponential distribution of the 5 minutes. Okay, so what this event is actually doing here is simply doing this action, the count increased by 1. Okay, so this is some things we can use to represent what is happening inside the simulation. I think this is the one thing that later, maybe in the future cases, I will illustrate to you more about what is this event diagram looks like. It's defined. But now just bear in mind that this is some things we need to know now. Another thing is I want you to have this sense of the comparisons between the different kind of the simulation. So now what we are talking about is discrete event simulation. In this kind of system, we actually have this world, then actually at our state, then we actually have these arrive events, which are discrete, okay, meaning that the state here changes only at the time when this event happens. Okay, so this one we call this as a discrete event simulation. But we also have another case, very, very similar, which we represent in this way. Actually, this is the system dynamics model. Okay, so what we are having here is they also have a state variable called a world, but here they actually have a continuous flow. Okay, then we have a flow rate to keep increasing the value in this world. With the rate probably is the same as this one. Okay, every 5 minutes, so meaning that every hour you have a basically just a flow rate. Okay, so every 5 minutes. So here it's like every hour you have a 20. Okay, I mean 20 units flow into this world, but it's actually continuously. Okay, continuous flow. And this kind of chart, we actually call this one a stock and a flow diagram. Okay, this is the stock. This is a flow, stock and flow diagram. Okay, then how to model this thing? How to model this thing is actually using either a software like some system dynamic software which are conducting the continuous simulation, but actually the mechanism behind is using a discrete time simulation. Okay, discrete time simulation means what? Meaning that because it's a continuous, but continuous is something computer cannot really simulate because I mean a CPU execution is actually discrete. Okay, in the sense that if you have like a 3.7 gigahertz, meaning that you know how many cycles a CPU is operating. So it's still discrete. Everything in computer is a discrete. So what we can do is that we actually discretize the time of this continuous flow. So that every time, every small time unit, we increase the value a little bit. Okay, we increase this value a little bit. Okay, so this is actually some things is executed in most of the continuous simulation. Probably, I mean, today I don't have the time to share with you the code of this thing for discrete time simulation, but just compare with what we are doing today. So probably after the session, I will quickly come up with a program I can share in the group so you can do a comparison, to see that what are the difference between these two. So in this case, both of the discrete event simulation and discrete time simulation, I will use the O2DES, okay, to do the modeling. But through reading the model, I mean, with the knowledge introduced today, you can understand the difference. Then you can see the difference. Then you try to understand the difference. Why we call this a discrete event and why we call it a discrete time. So probably the next session next week, if you have time, at the beginning of the class, I'll try to mention a little bit on these things. Then continue with our second topic, which actually using the O2DES net framework to construct a simple queuing model, or MM1Q or MMCQ. Okay, so I think with this I will end my session here. Any questions? Okay, so if you have any more questions, you can leave a message in the channel. Okay, yeah.